Morning, guys. Mr. Donnelly here, your favorite and only chemistry teacher. So today we're going to be talking about writing formulas with polyatomic ions, or technically we're writing formulas with ionic compounds that contain polyatomic ions. Behind me on the board, I have a list of some common polyatomic ions. I'll give you a list of many more polyatomic ions, but for now, the ones we're going to focus on while we go through this lesson are some of the common ones that are already written on the board. So let's take a look at how to use these common polyatomic ions, what they are, what they're made of, and their charges. So, common polyatomic ions. Up here I have ammonium, one nitrogen and four hydrogens. It's got a positive one charge. Down here is acetate. Acetate's made of three nonmetals, two carbons, three hydrogens, two oxygens. It's got a minus one charge. Chlorine, made of two nonmetals, chlorine and three oxygens with a minus one charge. What's nitrate made out of? What do you think? You're right. One nitrogen, three oxygens, and what was that charge? That's correct, minus one. Carbonate. Carbon, three oxygens with a two minus charge. Sulfate. Sulfur, and four oxygens with a two minus charge. And phosphate. Phosphorus, and four oxygens with a three minus charge. So those are some of the common polyatomic ions that we're going to be dealing with. There's many more, like I had mentioned previously, but these are the ones we're going to use in this video lesson for today. So let's take a look at how to use these common polyatomic ions when we're writing chemical formulas. So the first one we're going to start off with here, guys, is ammonium nitride. So ammonium nitride is often a confusing compound for students to come up with a chemical formula for. And the reason being is that ammonium is the only common polyatomic ion that I can think of right now that has a positive charge. But we can handle that relatively easily. And what's great about writing chemical formulas with these polyatomic ions is that we can follow some of the same rules that we used when we wrote our simple binary ionic compounds, like in the last lesson. So we have ammonium. First thing I'm going to do is find ammonium on my polyatomic ion chart. It's right there. And I'm going to write down the chemical formula with its charge, 1 plus. Ammonium always comes first, by the way, when writing formulas with these polyatomic ions. In fact, it's the only polyatomic ion I can think of that comes first. And the reason is because it's got a positive charge. Okay, it's got a positive charge. And when the positive charge, those cations always come before our anions. Anyway, the next part of that name that I have is nitride. Notice the ending, IDE. We learned about the IDE endings previously. That identifies our anion, that IDE ending. It also gives us a hint as to where we can find the anion. In this case, the anion comes from the periodic table. This is nitrogen as an ion. So I'm going to write nitrogen as an ion. It's ion forming. So it's N3 minus. Lucky for us, we can crisscross here. We learned how to crisscross last class, and you guys did really well with that. So I'm going to go ahead and do my crisscross. Recall that we don't bring the 1 down when we do our crisscross. 1 nitrogen is implied by simply writing the N. We do have to bring down the 3. Notice I'm not circling the negative charge because I don't carry that negative charge down. So what I'm going to do is I'm just going to bring that 3 down. Now I'm going to rewrite my formula. So I rewrite NH4. Notice I brought that 3 down. I'm going to write that 3 right there. And my nitrogen, I'm going to bring that down. Don't need to bring the 1 down because writing the N tells us that there's 1 nitrogen there. Okay? So the next thing I'm going to do is take a look at my formula. I notice that's really, really, really sloppy because there's a 3 beneath the 4. We have to organize this. We have to show what we mean. The way we show what we mean is by adding a parentheses. Now you might be wondering what I mean by show what we mean. Well, what I mean here is that I have three ammoniums. Not 1 ammonium, but 3 ammoniums and 1 nitrogen. So this is a correct chemical formula for ammonium nitride. All right, let's take a look at another one. So for this next one, what I'm going to write is, let's do potassium phosphate. So potassium phosphate. Potassium phosphate is another compound that contains a polyatomic ion. So potassium, as we know, is a cation. We can find it on the periodic table, and its symbol is K. So we're going to think K down. Group 1 elements always have a +1 charge. Phosphate, on the other hand, the ATE ending tells me the ATE ending or the ITE ending tells me that this is not something to be found on the periodic table. Instead, I have to go to my polyatomic ion chart, which is over here. So phosphate is PO4 3 minus. So I'm going to write PO4 3 minus. Okay? I'm going to do here what I've done previously, and that is cross the charges. Very simple. I'm going to circle the 3. That guy's going to come down over here. I'm going to circle the 1. Recall, I don't have to carry the 1 down because I'm only going to have 1 phosphate in this instance. And writing PO4 by itself tells me that I have 1 phosphate. So let's go ahead and do that. So I have K3 PO4. And that's going to be my chemical formula. Now, notice that that 3 below the K does not have a parentheses. I don't need it. And the reason why I don't need it is because K is 1 element. 1 element does not need a parentheses around it. 1 polyatomic ion does not need a parentheses around it. Okay? If I have more than 1 polyatomic ion, I need to represent with parentheses. All right? So this is a correct formula for potassium phosphate. Notice that there's no charges present. And the reason being is that this value, the overall charge for this compound is 0. All right? Let's take a look at one more. We'll do one more here. And for this one, we're going to use barium. Oh, let's go with barium phosphate again. Well, phosphate again, not barium phosphate again, which is phosphate again. So barium phosphate, barium, group 2 element, okay? Ba, 2+. Phosphate, Ate, gives a hint as to what we're dealing with here. We are not dealing with an element, we're dealing with a common polyatomic ion. In this case, that common polyatomic ion is phosphate, or PO4 3 minus, okay? So all we have to do here is we have to cross the charges, just like we did previously. Notice it's a 2 and a 3 that needs to be crossed. So I'm going to circle the 2, bring the 2 down, circle only the 3, circle only the 3, bring the 3 down, rewrite formula. Ba3 PO4 2. Now look, I have a single element or 3 single elements, no parentheses needed, but I have 2 phosphates. To represent 2 phosphates, I put a parentheses in. There I have barium phosphate's chemical formula. So that's barium phosphate. Next thing we're going to do is look at how to write chemical names from formulas containing polyatomic ions. So let's go ahead and do that now, just to get this over with, right? How long is this video so far? You guys get bored watching my videos, I know. We're only in 9 minutes and 7 seconds. So we're doing pretty well here. And we're going to knock this out pretty easily, pretty quickly here. So let's start off with KNO3. So now we're naming these chemical formulas. We're naming these chemical formulas that contain polyatomic ions. What I want to do here when I do these names is separate the metal from the nonmetal. The first metal from the nonmetal. In the majority of these, this will help you solve these problems. So here I'm going to first identify my metal. K is the metal. So I'm going to put a line here to separate the metal from the first nonmetal. See my metal and my nonmetals there? Notice that the nonmetal contains more than one non-metal. It has a nitrogen and 3 oxygens. That is a big hint for naming this compound. And the reason is that having 2 or more nonmetals after the metal tells me that I'm most likely dealing with a polyatomic ion. So now that I've separated these things out, I'm going to name them individually here, okay? So the first one is K. We know K. K is on the periodic table, and K is potassium. So all I have to do for the K is write potassium. Now the next part you might not be familiar with. First instinct might be for you to say nitride oxide, but that wouldn't be right. Or maybe you want to say nitrogen oxide, but that wouldn't be right either. These 2 elements are not to be considered separate from one another. They're one entity. Think of them as a person with a name. And I'm going to name that person or that polyatomic ion appropriately. So I have NO3. I'm going to go to my polyatomic ion chart to see if I can find it. So I'm going to go over here. It's not NH4, it's not C2H3O2, it's not ClO3 minus. It's NO3 minus, right? NO3 is called nitrate. So I'm going to call it what it is, nitrate. And guess what? I'm done. The name for this is potassium nitrate. Okay? Let's do another one. That one was pretty straightforward. We can do one that's a little bit trickier. So for this one, we're going to do RB2 SO4. RB2SO4. First thing I'm going to do is find my metal, where it ends, and where my nonmetals begin. Nonmetals begin. So let's see. RB. Okay, yeah, that's definitely a metal. So what I'm going to do is I'm going to draw a line down there, identify that RB is the metal, find my first nonmetal. The first nonmetal is an S, and I've got more than one nonmetal here. So big hint that this could be a polyatomic ion. So let me see. So I know my nonmetal starts here. Let me see if this is a polyatomic ion. So there's SO4. No. Nah. No. Nah. No. Yes. SO4 2 minus. That is called sulfate. So I must be dealing with a polyatomic ion here. Remember, I'm not going to find these on my periodic table. Instead, I'm going to find them on that chart that Mr. Donnelly handed out to you. So, did I just talk about myself in third person? Anyway, RB is my metal. Periodic table tells me its name. It's rubidium. SO4, 2 or more nonmetals together. It is a polyatomic ion. Find it on my polyatomic ion chart. Sulfate. Write its name down. So there's the metal. Here comes the nonmetal, or nonmetals in this case. Rubidium sulfate is the answer to my question. So there is another name for a binary ionic compound that contains a polyatomic ion. So let's do one more, okay? And this last one kind of disobeys the rule that I've been talking about when it comes to separating these compounds. This is the tricky one when we dealt with ammonium before. Okay, so let's just take a look at an ammonium example. So I'm going to write down NH4, 3 as a subscript, phosphate. Oops, big mistake there. Not NH4, 3 phosphate. Instead, NH4, 3 PO4. Okay? This is a fairly complex chemical formula, and this chemical formula does not have any metals. A little different than what we looked at before. Fortunately for us, when we deal with this compound, all right, with this compound, this chemical formula that we're dealing with here, is we've gotten a hint as to where the first polyatomic ion, polyatomic cation, starts and where the polyatomic anion begins. Okay? So if you look, the parentheses tells us where that polyatomic ion is. So I'm going to draw a line down between the two, just like I had done previously. All right? And with that line drawn, I'm going to name them individually. So NH4 is ammonium, and PO4, NH4 was ammonium, right? And PO4 is phosphate. So this is ammonium phosphate, and duly named, right? And correctly named, ammonium phosphate. So that's today's lesson on how to write chemical formulas with polyatomic ions and how to name chemical formulas that contain polyatomic ions. Once again, a great lesson from me to you, and take your time. The best way to get good at this stuff is to practice, practice, practice. Mr. Donnelly signing off until next time, your favorite and only chemistry teacher.